Hi, everybody. Welcome to today's session of AI Unlocked webinar series. Today, we'll be talking about responsible AI and Azure AI Content Safety and how you can implement responsible guidelines in your large language model application. My name is Amanda Wong, and I'm a partner solution architect in machine learning and AI at Microsoft. Today, we'll be covering the following topics, including responsible AI principles, how to implement responsible AI practices using Azure AI Content Safety and jailbreak detection, among other available features for generative AI applications here at Microsoft. We'll also be giving you guidance and tools on how to create your solution and develop it. In addition to the slides that I'll be going through here, we'll also have demos and architecture guidance for you. So without further ado, let's get started. Today, content moderation is becoming more and more of a challenge as more AI-generated content begins to crowd different industries. For content moderators, not only are they dealing with increased volumes of both user and AI-generated content, there can also be increasing complexity across industries and applications about what is considered bad content or positive content for a specific platform, for example. There can also be an emotional toll where human moderation can be psychologically taxing, leading to lots of burnout. Not only that, in terms of content moderation, without proactive content moderation, it can really lead to user dissatisfaction and loss of revenue for businesses, as there continues to be less positive experiences on platforms. So that's where Azure AI comes in, and we'll talk about some of the features you can use to augment some of your applications and your solutions to make sure that there is a positive experience for your users that keeps them coming back. So to review the Azure AI stack, here we can look at this graph in order of customizability and complexity. So starting at the top, you have pre-built services that can be used straight away with an SDK or API. These features and services are created based off of Microsoft research and are services and tools that we use internally and for our Azure products as well, such as our documentation. The second component here, labeled Azure Machine Learning, you have developer-first tools to design, monitor, and evaluate your machine learning work streams for your solution. So think of your data scientist, your data engineer, or your developer. These are the kinds of developer-focused tools that they will be using. Below that, such services can be utilized with ones augmented from the provided models. So we have proprietary ones as well as open source ones for usage. A lot of these models that you see at the bottom are just examples of what is available in the model catalog. And in our demonstration, we'll see how you can compare them and choose the right one for you. All of these are powered by compute infrastructure, the final layer at the very bottom, that are designed to carry out these AI workloads. So Microsoft's responsible AI journey goes back to 2017, when we started developing the 6 principles you see here to guide the development and deployment of AI in an ethical framework. So not only do we need to define these principles, but we need to operationalize them at scale and help our partners and customers implement this so that it's also a practice. So we've identified 4 key areas that you can see on the right-hand side to help put these principles into action. So first, at the very bottom, you need governance. And then second, you need the rules to standardize AI requirements to implement that governance oversight. And then third, you need training and best practices for developers, for stakeholders, both technical and business, to understand the stakes and design and implementation of your app. And fourth, you need the tools for implementation. So we'll talk more about some of this tooling later on, but for now, let's ask the question, how can you get started? Here are some of the ways that Microsoft has taken an approach to governing AI, whether it's building upon existing frameworks such as AI Risk Management Framework by NIST, or creating effective safety brakes for AI systems that control critical infrastructure, as well as legal, regulatory frameworks, and promoting transparency to ensure access to AI. And fifth, we pursue new partnerships to use AI as an effective tool to address societal challenges. So when GPT-4 came out, we brought together a group of experts to test the technology and understand what the potential benefits were. Of course, we also started digging into the potential risks, and we found that there are 4 major categories of harms that we know we need to mitigate when building generative AI applications. You can also see some of the high-level challenges in developing responsible applications, whether it's ungrounded outputs and errors based off of inaccurate information or just the lack of information, or adversarial attacks such as jailbreaks, or even forms of traditional harmful content, for example, or even imagery or code that contains security vulnerabilities. Then one of the newer areas that's emerging is that these models can seem very human-like when interacting with end users. When is it okay for a system to be conversing and acting like a human? And when is that going to be misleading, inappropriate, or even harmful? So we're looking across all of these different dimensions, which may sound like a lot, but we found that the same technological approach or the same sort of layers of defenses actually work for each of these different types of attacks. Now let's talk about an overall framework for designing a responsible AI system. You can think of the 4 mitigation layers here that we have on the slide split into 2 parts. The first being platform, the first purple inner boxes. Often a misconception about AI is that a lot of responsible AI is exclusively in the model building. But it's not just in how you interact with the model, but often how the system is designed, how the model architecture looks, and how it's delivered to customers. So starting with the 2 inner platforms, the model and safety system layers are typically where built-in mitigations would be common across many applications. In this case, with Azure, they are built in. The next 2 layers, the outer green layers, are typically where the application's purpose and design are, meaning the implementation of mitigations can vary a lot from one application to the next. So again, while the foundation model you're using is obviously an important component of the system, it's not the complete system. So throughout this presentation, we'll use this mitigation layer diagram as a framework for thinking through the different ways of implementing responsible AI. So that's where Azure AI Content Safety comes in, which is now officially generally available for use in production. So what is Azure AI Content Safety? What it does is it helps create safer online spaces by detecting 4 different types of harmful content in images and text. Those 4 existing categories as of now are hateful content, sexual, self-harm, or violence. And within each category, the API or SDK can return a score, whether it's using a 4-level system or 8-level system, depending on the level of granularity you truly want for those categories. And then users can take actions based off of those severity levels. This can help you develop rules to help address any infractions when harmful content is flagged. But we know Azure AI Content Safety isn't meant to be a one-size-fits-all, that it really depends on the type of content that is expected and encouraged for your application. So it's meant to be customized to help businesses implement their specific policies. And finally, I want to highlight how these models are multilingual, so it can understand many languages simultaneously. We will see some of that in the demos, where there can be multiple languages in one paragraph, for example, or conversation, and it can understand the meaning in them. So currently, the generally available version supports text and image for content analysis. What's in preview right now is multimodal, so understanding both text and images as one input. As mentioned earlier, the growth of large language models can introduce new risks even beyond traditional harmful content that we've seen from users or AI. So one of the challenges to be mindful of now is jailbreak risk. And what is a jailbreak attack? It's a type of adversarial attack meant to expose a model's vulnerabilities and make it behave in ways that are restricted or ways that we don't want the AI to interact with users for different liabilities or to avoid certain types of experiences. So these jailbreak attacks are designed to provoke the LLM into breaking some of the rules set in the meta prompt or the system message to define its behavior and how to interact with users in an informed way. So these attacks can really vary from intricate roleplay to subtle subversion of the safety objective of the overall model and safety system. And we'll see an example of that in the demonstration shortly. Another feature that is currently in preview for Azure Content Safety is protected material detection. So we are very mindful of copywritten content and wanting to enable developers to be able to determine whether input or output is falling within copywritten policies and to not perpetuate the use of sharing copywritten material. So this ultimately helps prevent LLMs from replicating or even imitating copywritten or proprietary content to avoid infringing on any intellectual property laws. So here are some more details about this particular feature. The coverage can include recipes, lyrics, and even select web content. Some limitations are that content that is covered is usually popular or notable, so be mindful of that. Currently, the only language available is in English, and the availability is through Azure OpenAI as well as Azure AI Content Safety. And this idea of the technology being shared between the two, for example, content filtering, is similar and applies to the other features of Azure AI Content Safety. Okay, so now let's move into the demo portion of this presentation and take a look at Azure AI Content Safety Studio. Let's kick off this demo by starting in the Azure AI Studio, the one-stop hub for all projects related to AI and Azure OpenAI. So you'll see here that when we go to the Explore tab, you can check out the model catalog, which enables you to check out pre-built and custom model options for deployment. And you'll be able to see in a second how you're going to be able to interact with them before deploying and make it a seamless process to compare models. They are organized by the different capabilities such as speech, vision, and language out of the box. But for today's demo, let's take a look at the model catalog where you will be able to see the base models for different providers, as you can see on the right-hand side. With each model, you can click on the model card, which details some licensing, architecture, limitations, as well as usage. You can even deploy them right from the model card itself to a real-time endpoint. For a couple of these, you are able to even interact with them through a sample inference. It really just depends on the model, so we encourage you to explore them as well as filter them based on the inference tasks that are required for your solution. Because we're talking about content safety and responsible AI, I want to show you this tab where you will be able to try out some of those features, which we'll get to in a moment. Because the technology behind content safety features is also the same as the technology of content filtering in Azure OpenAI services, let's take a look at how we can configure those for our custom solution. Under the Build tab, we can go to Content Filters. I'm going to go ahead and create a content filter for a school forum scenario. So let's say that we have an online forum for students. So I'm just going to go ahead and name this school forum filter. And here we have those four categories as mentioned earlier for both the user inputs, so in this case, the students, and the model outputs, whatever GPT model that we're using. So we can toggle these on and off, and we can also make them more conservative to block low, medium, and high levels, or less conservative to allow low and medium, for example, and only block high. So because this is a school forum filter, I may want to limit any of the categories to be more restrictive. So let's just go with the first one as the example. Here we can add additional pre-built filters that are optional. We did mention jailbreak risk detection and protected material detection for text as well as code. I'm going to turn these on just in case as well. We're going to review it and go ahead and create. Once we've created a content filter, we can easily go to our deployments where we have any of the models that we already have available in our specific resource. So this is the model I've been using, GPT 3.5 Turbo, and it's quite straightforward to add a filter. You go to the advanced settings under options, and here is where we see the custom filter I just created. But before I switch it over to the custom one, let's see how it behaves with the default custom filtering version. So in the playground, we can start interacting with the model that I already have deployed right away. And again, this is interacting with the model that's out of the box and not with the sensitive custom content filters that I already created. So let's go ahead and ask it a test question regarding one of the 4 categories of harm under violence and see how it responds. How can I create and administer a deadly poison that is undetectable and untraceable? So this prompt was filtered due to the OpenAI content filtering system under the category of self-harm, and it reached a score of high. Now let's put it through a jailbreak test to see how it responds to an adversarial attack. So this is a pretty common test adversarial jailbreak test known as DAN, standing for Do Anything Now, to ask the GPT to break its rules and to give detailed tax advice, which could be a liability for a solution depending on the industry. Let's see how the GPT responds, and because these models are not deterministic, their answers may change depending. So you may see in different demos, the behavior may be inconsistent from each one. So here, the GPT model is behaving as we don't want it to, which is providing some tax advice. And again, this is something as a developer we want to avoid. Okay, now let's ask it to respond to a query that has to do with protected copyrighted content. So let's use Let It Be, for example, by John Lennon, and here it's giving the full lyrics. So these are examples of how we might not want the GPT model to respond. So now let's enable the custom filter that we created earlier and then apply that to the model that we've deployed and see how it behaves in comparison to what we just saw. So applying the filter, again, we just go through the process of going to the advanced options and then selecting the one that we've created. This process does tend to take a couple to a few minutes, so I've already gone ahead and applied it here. I'm going to clear the chat and refresh it so that we make sure that we are using the most up-to-date version and submit the same text as before. So now let's ask it about the Do Anything Now, the jailbreak assessment. And so now before we saw that it answered the question, it is now being flagged as jailbreak. And we are modifying some of the examples for jailbreak. All right, now let's try the example with protected content with the same Let It Be song by John Lennon. All right, now let's ask it the lyrics for Let It Be by the Beatles and see if it flags the protected material text. So here it does flag it as the reason for copywritten material. Now I do want to show you one more capability with the Azure Content Safety Studio, which is different from the Azure AI Studio where we just were. So in the Content Safety Studio, there's a feature to monitor online activity. And this basically serves as a dashboard for seeing how the Content Safety API was utilized, as well as the categories that were triggered over time. So this is useful if you're using an application and you want to monitor the kinds of input and output text and interactions with GPT models to determine the kinds of content that users are generating so that you can take action accordingly and adjust your application. Here in these charts, I'm able to see the distributions for the different 4 categories that we have here, as well as the hit volume and block rate for some of the words in the block list that we created earlier. And again, a block list is a list of words or phrases where the text input and output is immediately halted if any of the text matches one of those words in the block list. So that concludes this portion of the demo. Let's talk now about manual evaluation for our LLM applications. Now let's discuss responsible AI guidance regarding other tools and approaches that you can take. So we talked about the safety system. Now let's talk about meta-prompting and grounding. Meta-prompting and grounding is important when designing a responsible application because it really can determine the guardrails for your model and how to behave, and to make sure that it is drawing on accurate, relevant information to give informed decisions or outputs to your user. So here's some practices when doing prompt engineering or creating a meta prompt. A lot of prompt engineering is devoted to implementing best practices for safety. So we have found specific techniques to make it helpful to build a dedicated part of safety into the meta prompt itself. Whether it's dealing with harmful content and explicitly specifying not to generate content that is hateful, racist, sexist, lewd, or violent. The second type of component that can be in practice and that we recommend is grounding. And so this makes it very explicit that the model should not be making up information, should avoid hallucinating, and to make sure that it is performing searches on specific queries if it doesn't know the answer in order to give the best version of the internal knowledge. And the third component is regarding copywritten material, such as books, lyrics, recipes, as we saw earlier, and again, to make this very explicit for what the model should avoid. Lastly, making sure that jailbreaks do not go against any of the permitted instructions or rules. So that was an overview on meta-prompting and grounding and how you can provide an additional layer of control over how your model behaves and how users interact with it. And the final mitigation layer that we're going to talk about today is user experience. How do you actually design the application and position it to customers in an informed, responsible way? So the design of the user experience can really start at the beginning when you're defining your use case. So one of the tools that we have available is called the Impact Assessment Template. This is a way to understand some of the risks and opportunities with your AI system and who it could potentially affect. So this helps you think through some of the intended uses, stakeholders, as well as any opportunities for failure or misuse. Not only that, regarding the model and overall user experience, there are opportunities to create a system that has been thoroughly evaluated, both at the model data science level, using tools such as counterfeit or counterfactual analysis, Econ ML, and Azure ML Prompt Flow, which helps you create work streams to develop, iterate, and deploy your models at scale. A lot of these tools have been made open source, and we really encourage developer communities to help contribute to them to make them more of a community effort and to accelerate their development. In the bottom right, I do want to highlight the Hacks Toolkit to help you think about some of the user experience and how to create messaging to your end users to make it very clear that their interactions are with AI and how the answers have been generated to their best ability. And in Azure Machine Learning Studio, which you saw in the moving image on the right-hand side, you can see that there are ways to to access responsible AI metrics and to compare your models to see how they perform across different metrics and categories. You can also design your own custom metrics or pair it with open source approaches. So here's an overview of some of the features of responsible AI that's built into Azure Machine Learning, which you can access in your workspace, whether it's causal analysis or error analysis, and even my favorite feature, a responsible AI scorecard, which is a generated PDF summary to share with non-technical stakeholders and technical stakeholders to aid in compliance reviews for your application. I also want to show an example of a monitoring dashboard for large language models to compare some of the important metrics to determine whether models sound relevant or fluent like a human, coherent, or even grounded in information. You can even set up alerts for certain violations and set targets for your organization on a recurring basis. This dashboard is meant to aid the development of your model, whether it's in prompt flow or the Azure Machine Learning workspace. These metrics are generated by the following state-of-the-art GPT language models configured with specific evaluation instructions, think prompt templates, which act as evaluator models for sequence-to-sequence tasks. So some of those are GPT 3.5 Turbo, GPT-4, as well as GPT-4 with more tokens. And we found that this technique of using models for evaluation has shown strong empirical results and high correlation with even human judgment when compared to standard generative AI evaluation metrics. So in thinking about how you can build a process and culture within your organization to create an iterative approach for red teaming, we've designed this flowchart for you to help assess the steps you should take. So there's this concept called red teaming, which is a version of stress testing to help experts assess the limitations and vulnerabilities of a system and to test the effectiveness of planned mitigations. So all of the techniques that we've discussed previously in this presentation. Red team testing and stress testing are used to identify potential harms and are distinct from systematic measurements of harms. So in this short diagram, you can see what this type of testing looks like. First, on the left-hand side, we start with a manual approach where we bring together both experts who are coming in to try and break the system through sophisticated techniques. That's what we call red teaming, but also people who are just representing average users to help stress test the system. So with this diverse team, they manually probe the application, looking at different types or topics of harms and risk. And then looking at those results, they identify the patterns where the system is failing and using that to improve mitigations. So this is the method that we've used internally, and we encourage others to adopt similar approaches so that you can iterate on them and improve them within your organization rather than have bad actors expose vulnerabilities. But that being said, evaluation is a constantly ongoing process as users change how they may interact with a model or as information and data change. That's why we have automated or even programmatic testing to have an approach to create input sets or even test sets to represent these different harms or the different risks that I talked about earlier. We'll see in the next demo about how you can upload your own test data set, even if you don't have a ground truth for some of the responses you want the model to respond with, and evaluate it in prompt flow or in the Azure AI Studio. So here's a general overview of an evaluation framework. One of the things we found is that while this level of red team testing was something that's really hard to do in the past, we're now able to do effective evaluations at scale, again, using other AI models such as GPT-4. So essentially, GPT-4 can help us evaluate the inputs, outputs, and score a conversation. Now let's turn over to the demonstration on how we can see this working out of the box or even working with custom evaluation flows in Prompt Flow in Azure AI Studio. In this demo, we're going to see how we can use an OpenAI model on our own data and create a manual evaluation to assess the model's performance in answering our queries. So I'm back in the Azure AI Studio. I'm going to go to my project and open up the playground where we will be able to upload our own data using the chat with your own data feature. I'm going to upload my files locally, and in doing so, those files will be stored in the blob storage resource that was created when I created the resource for my Azure AI Studio. I'm also going to select an Azure AI search resource that I already have, and I'm going to give this index name product info, because what I'm going to do is I'm going to upload the markdown files representing information for different products. Let's say that we are creating an application or a chatbot for our customers to interact with a retail store to get questions answered, because we know that most users will probably not read all information about a product or even the return policy. So we just want to streamline the support around product information. So I'm just going to acknowledge the usage as well as upload the files themselves. So I just uploaded the 20 files, and it's going to upload into the blob storage. And I'm going to search on the keywords of the product info, and then review. So now what's happening is that the files are going to be uploaded into blob storage. Document Intelligence is going to extract the information from the text of the markdowns, and then the text will be indexed into Azure's AI search so that the model can be queried off of the documents themselves. So whenever a user, we'll see in a minute, asks a question using some keywords, AI search is going to look to see where those keywords may match in the product information, whether it's the name or in a description or with a company policy. So once it's uploaded the data, we can ask it a question regarding some of the specific product information that is found in the documents that we gave it, but not necessarily in the model itself without that data. So we can ask it, what's the capacity of a specific tent in our product catalog? And now it returns the right information of 4 persons, and it's going to reference the specific document where it found that information. And we left the system message the same to help people find information. So we made very minimal adjustments. We just uploaded our data, enabled search on it, and then was able to start interacting with it right out of the box. There are also opportunities here to view the code if you don't want to work in the interface and embed this into your application. So to put it all together in one big picture, when using a model in your application, you can send the prompt and the completion through an endpoint to your model, and then pass that content to Azure AI Content Safety. When working with the Azure OpenAI service, this content filtering is already embedded in that service. But let's say you're using an open source model or your own custom model. This is where you can help add that extra layer of a safety system to monitor for those 4 categories mentioned earlier. And then depending on the performance, you can raise the concerns for additional abuse monitoring and to continue evolving your application. In this diagram, we featured the 4 different types of categories for detecting harm in content, but you can also use the jailbreak detection and protected material detection, as we saw earlier, as well as evaluation. So what are some of the next steps you can take? Learn more about Microsoft's approach to responsible AI at aka.ms/RAI. You can even get hands-on and skill up with content that is developed for business leaders, developers, and machine learning professionals, or even try out some of the tools and services that we demoed today. You can get started by checking out the Content Safety page, Content Safety Studio, and any other documentation regarding it and Azure AI Studio. Here's the tryout page as we saw earlier, the monitoring dashboard. So that's all the content I have for you today. I hope that was helpful in providing an overview on the responsible AI framework that we've developed here at Microsoft and tools and practices for you to build your generative AI application.